Problem number 29 refers us back to 28, and that is where the driver had to deliver bread to 5 stores, and we wanted to know how many ways he can do that. Now, in this case, it says that the stores are in 2 towns far enough apart that the driver wants to make all the stops in one town before going on to the next. So we don't just have 5 stores in one town. Now we have 5 stores that are separated in 2 towns far enough apart. Let's make all the deliveries in one town, then go to the next. So I think our first decision here is, which of the 2 towns do we want to deliver bread first? So there's 2 towns, and we could go to either one, so there's going to be 2 ways to make that decision. Then, once we've made that decision, let's count the number of ways that we can make the stops in each town. So we've chosen a first town. Now suppose we choose, there's 5 deliveries we have to make. So say this one has 3 deliveries, so we could choose any one of those 3 stores to deliver. So that's going to be 3 factorial, right? 3 stores, then 2 stores, then 1. And then we go to the other town, and there's only 2 stores left, so we could choose any one of those. Now, don't worry about the order here. If once we choose a town, suppose it had 3 stores and then 2 stores, that would be this count. But suppose that we made this choice, we choose any one of those 2 stores, and then that town has 2 stores in it. So we have 2 factorial, and then the other town has 3 factorial stores. And you know by multiplication is commutative that these numbers here are going to be the same. And when I make that computation, I come out with 24 ways to do that. In problem number 30, we are told that of 14 new programmers hired by a major software company, 3 will be selected to work on programming languages, 4 for word processing software, and 5 on spreadsheets. Now, what we have assigned here, what we're going to assign here, this is a total of 7 and 5 is 12. We have 12. That means that there's 2 left over that can be assigned just to do anything. So let's make this count. Out of the 14, let's choose any 3 to do the programming languages. And then there's 11 left, right? Out of 14, we chose 3. So 14 minus 3 leaves 11 left that we can choose any of those, 4 out of any of those 11 to do the software, word processing software. And then there's 7 left. Out of those 7, let's choose any 5 for the spreadsheet software. But that leaves 2 left, and we'll choose both of those 2 for just any other positions. So this is what we're looking for. That's the count that we're looking for. And when I made that count, I got this number here. I got 2, and then 5, 2, 3, and then 5, 2, 0. In problem 32, we want to know out of how many 5-card poker hands can we get hands that have exactly 2 aces, 2 cards of another denomination, and then 1 card of some other denomination. So let's start this way. First of all, let's choose the 2 aces. So there's 4 aces. We want any 2. Now we want to go to a different denomination. So there's 13 denominations altogether. We have used 1 of them already, like the aces. So now what we want is a different denomination. So there's 12 left, so we have 12 choices there, right? We can choose any one of those 12 other denominations. And then we want 2 cards in that denomination. So there's going to be 4 of those denominations. We'll choose any 2 of them. Now we want yet another denomination, so there's 11 remaining denominations, and out of those 4 cards, we want any 1. So this is the count we're looking for, and when I did that on my calculator, I got 19,028.